Welcome, everybody. Good afternoon. Welcome to BSides Las Vegas. What is this? What is this?
Breaking Ground.
Breaking Ground. Thank you. This talk is at your service, and our speakers today are Shay Shavit and Daniel Abeles. A couple announcements before we get started. We'd like to thank our sponsors, especially our Inner Circle sponsors, Critical Stack and Valley Mail, and our stellar sponsors, Amazon, BlackBerry, and the National Security Agency. It's their support, along with our other sponsors and donors, that make BSides possible. These talks are being streamed live, so as a courtesy to our speakers in the audience, we ask that you set your cell phones to silent position. If you have a question at the end, please hold up your hand and I'll bring you the audience mic so that we can have your question on the video for the YouTube audience. And that's it. Let's get started. Please welcome Shay and Dan.
Thank you. So thanks for joining us and welcome to our talk, At Your Service, Abusing the Service Worker Web API. My name is Daniel, this is Shay. We are both security researchers at the Akamai Threat Research Team. We both breathe and live web security, and if you have any questions, please feel free to reach out at our Twitter account or after this session. So about 6 months ago, Shay and I had our usual morning discussion, and unlike any morning discussion that we have, this one was actually interesting. We brainstormed on how we can enhance low to medium attacks using Web API to make them a more meaningful and high impact attack. And that research, that brainstorm led us to a research that we're presenting to you today. So we're going to talk about what is the Service Worker Web API and how can it enhance those low to medium attacks to a more meaningful, high impact, powerful attack. We're going to show some abuse scenarios that we have found out during our research and some way to mitigate them. So our web browsers, Chrome and Firefox and so on, run JavaScript as their main programming language for the client-side application. And that JavaScript is single-threaded by nature, meaning that every web page you get a single thread to handle all the client-side operations. Now, sometimes we have extreme load on the main thread, meaning that we have some expensive tasks that are going out in our browser. This can result the UI being not so responsive. Now, there is a question, how can we maintain the UI responsive and do those expensive tasks? And that's where the Web Workers API came in. It let us the ability to delegate those heavy lifting, those heavy tasks into other threads and maintain the UI responsive. So web workers are basically background threads that run in our browsers that run JavaScript. They are very similar to the main thread. They share a lot of common features, but they have some restrictions. They have to be loaded from the same origin, meaning they cannot be loaded from any other third-party domain. And they don't have direct DOM manipulation rights, meaning that if they want to manipulate the DOM, they have to communicate with the main thread using the post message API. And then the main thread is the one that is doing the DOM manipulation. Now, those web workers are great, and they're still being used today widely over the internet. But they have some limitations. If we want them to be applied on every web page under our application, we have to load them manually on every page, which might be expensive. And they are bounded just to a single page. And this is where the Service Worker API came in. It has the ability to create web workers across a wider span of a scope and reduce that expensive load time. A service worker is basically a type of a web worker. It sits between our application and our browser and the network. It acts as a network proxy. And it has a much wider scope than the web workers. Once we register a service worker, it will be applied under all web pages under the scope of the service worker. And we'll touch about the scope a bit later. Also, in terms of the lifespan of the web worker, even if we shut down the browser, we shut down the computer, and we turn it back on, if we go to a web page under the scope, the service worker will still be spawned under that page. Now, why should they even use those service workers? Well, first of all, they can handle the network requests between our browser and the server, meaning they can intercept and inspect. They have some sort of full visibility into the request and response. This can be very good because they also support a cache API, which is different from the standard browser cache API. So we can cache those responses into a different cache and then return them in a later stage. And they can also offer our clients an offline experience to our application. Using the cache, we can store an offline version of our application. And where our clients are losing internet connection, we can offer a different version of our web page, of our web application for an offline experience, which is very good. In terms of browser support, it is widely supported over all major browsers, except, as you might have guessed, IE. It's mainly because IE doesn't support natively the Promise API, and service workers are asynchronous by design. They cannot run any synchronous APIs, like XHR, for example. So IE is still behind. In terms of the life cycle of the service worker, they have three main stages: the registration, installation, and activation. Once they're done, it can start listening to events and messages. And once the web page is closed, the thread dies now, or gets terminated. Now, terminated doesn't mean it gets deregistered. As I said, even if we close the browser and we open it once again, under the scope of the service worker, it will be spawned once again. To register a service worker, we use the register function that gets as the first parameter the file where the service worker file exists in the server. It has to be a physical file. It cannot be any in-memory object, like a blob, for example. And that function returns a promise that when resolved, we get information about the scope. Now, let's finally talk about the scope. The scope is a crucial concept on the service workers. It determines where the service worker will be spawned on. It's the activation condition for it. By default, it is the path where the JavaScript file is located in the server, meaning that if the file is located under, let's say, the /static folder, every web page under that folder will be activating the service worker. Now, we can easily reduce the scope by setting the scope parameter. An example from /to/profile, it's very easy to reduce, but we can also increase it, but it requires another step. It requires the server to respond, to give us the file with a special response header called service worker allowed. The value of that header defines the maximum scope the browser is allowed to define. Here we can see an example of a failed registration where the file resides, as I said, at the /static folder, and we try to set the scope to /. Now, the max scope for it, by default, it's where it resides, which is /static. If we try to set it to /, we get an exception on the registration function. Here we see an example of a successful registration because, as you can see, we have set that response header on that file. So it got successfully registered. Now, you might be wondering what happens if we have two service workers installed in our browsers. Now, if we have two of them under the same scope, the most recently one will be the one that gets activated. So if we had one under scope A, and now we have another one that gets registered, the most recent one is the one that will be activated under every page. If we have two of them on overlapping scopes, in example, /uploads, when we'll visit the /upload/files, only the innermost one will get activated. In here, the /uploads service worker. Now, they can also import scripts from other files. In example, if we have any logical code in other file, we can import that file, and that content will be loaded in runtime. Now, this is, by the way, how we maintain the legit service worker functionality in our malicious service worker that we are uploading in our abuse scenarios that we'll show in a second. Just like web workers, once again, it has to be installed under the same origin. Again, we cannot load it from any third-party domain. Now, once it was successfully registered, the install event occurs in the service worker. This is the perfect step to start caching if you like to open a cache. And this event also occurs when the service worker has changed, even in 1 byte. That's the criteria for the change condition. Once that event is successful, the activate event occurs. In this stage, we can clean up any older caches that were opened in the service worker context. So we can clean them up, delete them, do whatever we want. And in this event, we can also call a special function called clients.claim. By default, open pages that were opened before we registered the service worker are not controlled by the service worker, if they're under the scope, of course. So with this function, we can override this behavior and claim our rights on those clients or tabs. Otherwise, they must be reloaded. Now that we have done with all the steps, the registration, the installation, and activation, we can start listening for events and messages. One of the most crucial events for us is the fetch event. The fetch event occurs every time the browser tries to request a new resource, an image, a JavaScript file, a web page, whatever. In this event, we have control over the entire request, meaning we can see the headers, the status, and the body. And we can respond either with a fetch request to fetch the resource from the server, or we can respond with the cached version we stored on the last event. Specifically in Chrome, you can find them under the Developer Tools tab. Under the application bar, you can see the service workers from all domains that exist in your browser. And you'll be surprised how many of them exist in your browser today. So we talked about what are service workers and what they're good for, but now we'll talk how you can abuse them, as we said, to enhance those low to medium attacks. The first scenario is a category called response modification. In this scenario, we have a website that has two requirements. The first one is that we have a file upload functionality, meaning that we can upload any JavaScript file, and most importantly, we can retrieve them, and that we have an XSS vulnerability in the app, meaning that we can inject JavaScript code in the context of our victim's browser. Now, all of the following scenarios under this category abuse the fact that we can attach to the fetch event in our malicious service worker and manipulate the requested resource. We start by uploading the malicious service worker to the website. We trigger the XSS that we have on the website to register the malicious service worker, and then we attach it to the fetch event. In this point, we can modify the response of requested resources. Now, during our research, we found three main scenarios that could apply in this category. We can persist XSS, we can cause local denial of service, and we can serve phishing or defacement campaigns. Now, how can you persist your XSS? On the last step, where we have attached to the fetch event, now we have control over the response for that resource. So we can re-inject our code under every page under the scope of the service worker, meaning that we have just expanded our scope for the XSS for every page under the service worker scope, rather than just the page that suffers from the XSS. In this example, we have a website with a page that definitely doesn't have an XSS because it said so. And now we're going to trigger the XSS on a page that suffers from the XSS, as we said, to register the malicious service worker. We open the developer tools to see that indeed we have that service worker up and running in our browser. And now we'll try to go to a page, to that page that didn't have the XSS, and you can see we now have the XSS up and running under that web page. So the second abuse scenario is causing local denial of service. Again, under the third step, we have visibility into the fetch event. Now, instead of modifying the response, we can just deny it. We can deny images, we can deny CSS files, we can deny everything we want. In this scenario, we have the same application, but now a different page. We first validate that we have no service worker installed under this application. And as you can see, we have some very interesting data. Now we'll try to trigger the XSS again on the page that suffers from the XSS. Again, to trigger the register function to have the service worker up and running. And we have validated it is up and running. And when you go to a page that definitely exists, we get a 404 not found. Now, when you go to the network tab, we can see that the page itself was received from the service worker, and it gave us that 404 not found. The third one refers to phishing or defacement. Again, on that third step, instead of serving or denying that resource or injecting our code, we can just serve alternate content. In this scenario, in this application, we have a login page. We put our credentials and we submit the form, and you can see it successfully works. Now we'll try to trigger again the XSS that we have in the application to register the service worker. And now we can actually verify the service worker is installed. We will reload the page. And now, once again, we'll submit the form with our credentials. And this time, when we submit the login page, we were submitted to a different domain, to a malicious domain, because we had control over the form itself, because we had visibility into that response for that request.
All right. Does it work? All right. So now that we have a better understanding of what exactly service workers are, what they're used for, and a couple of pretty straightforward abuse scenarios by modifying the responses, let's look at a little bit more advanced abuse scenarios. So in this particular one, we're going to talk about how can you leak sensitive data, user-sensitive data from sandbox domains. Now, to those of you who are unfamiliar with sandbox domains and what exactly they are, those are domains that usually are meant to host user-uploaded files, untrusted user-uploaded file, but separately from the main application. That's why if you have some sort of a maliciously uploaded user file into the sandbox domain, it won't affect at all at the main application. So the user won't be compromised. There's no real vulnerability to be exploited on that sandbox domain, and there's not a whole lot you can do. Because those sandbox domains usually don't carry any cookies, no authorization information. There's no way to actually connect the sensitive files back to the user or steal them or anything at all. Those files, most of the time, are publicly available, meaning that if you have the path to the sensitive files, you can access it without needing to log in or have any cookies or anything like that. Now, the reason that's possible is because most of the time when we upload those type of files to the sandbox domains, the actual file path, the file name, gets heavily obfuscated, or it's being completely randomized, meaning the actual uploaded file name resembles nothing as the actual file that now resides within the servers. As a result, many vendors tend to ignore XSS vulnerabilities on those sandbox domains, because once again, even if you've gotten somehow an XSS on the sandbox domain, most of the time, it would be by uploading an HTML file containing a malicious script, and that's it, because once again, those sandbox domains are meant to host static files, user-uploaded files. So that's pretty, but something that is very likely, actually. So there's not a whole lot you can do with an XSS. You can still credential. There's no sensitive data to be collected other than the path, but once again, you can't really access the path unless you know it somehow. A couple of examples of such sandbox domain is Google user content versus google.com and fbcdn.com versus facebook.com, which once again, you have the main application, google.com, versus the actual place where you upload your sensitive files, which is Google user content, separate, different domain. So in this abuse scenario, we're going to presume the following. The first thing is that we have the main application residing in BSidesPhotos.com. That would be our main gallery application. And the actual sandbox domain would be called BSidesPhotoSandbox.com, and that's where all the sensitive files would be uploaded to. And let's assume that we somehow find an XSS in the sandbox domain. Now, most of the time, once again, that would be by simply uploading an HTML file containing the script tag, and that's it. So as you can see, that's what I was just describing. You have the main application, BSidesPhotos.com, but the actual picture resides in the sandbox domains. So for us to actually take abuse of that scenario and somehow leak that sensitive data, we're going to upload a malicious JavaScript file, which contains the service worker code, like in the previous scenarios, into the sandbox domain. That's very plausible because of the way those sandbox domain works. They're meant, once again, to host user-uploaded files. The next thing we're going to do is trick the user to somehow visit our XSS. We're just going to send him the XSS payload under the sandbox domain. And that XSS, once triggered under the victim browser, is going to install the service worker. That service worker is now installing and is currently running in the victim browser. So we have a service worker which is listening for all the requests and responses going through the sandbox domain. You might be getting where I'm going with this. So the next time the user is going to visit the BSidesPhotos.com to view his cute dog pictures, and click on one of the pictures, which will trigger a new tab opening of the sandbox domain, or rather will try to download the pictures for his own enjoyment. The service worker will start running in the background, and remember, this is a malicious service worker that we control. Once the service worker realizes that a resource is being fetched from the sandbox domain, it's just going to leak that sensitive path, that sensitive publicly available path back into the user, and we can just visit that file for our own enjoyment. So we've got a quick demo around here to show you exactly what it would look like. We have a gallery application showing the cute dog pictures. She's called Chiquita, and she likes to snuggle. As you can see, she's very cute, at least in my own opinion. And we're going to actually visit now the sandbox and domain to trigger the XSS on the victim browser. You can see now that we have a service worker installed and running in the sandbox domain. That was done via the XSS. So once we're going back into the photo gallery, once again, to view my cute dog Chiquita pictures, and we're going to show you in the bottom our C2 server listening for all the requests coming from the service worker. And once the victim will click on one of the pictures, once again, to view it, you can see the actual sensitive file, the sensitive path being leaked back to the attacker. So we somehow, by just abusing the service worker API and an XSS on the sandbox domain, which most of the time there's not a whole lot we can do it, we can leak those sensitive files back to the attacker. So to recap exactly what we saw just now and what we need to do to actually abuse that scenario, we need to upload the sensitive service worker file into the sandbox domain. We need somewhere to trigger the XSS on the victim browser. The service worker will activate and start running in the background. And whenever a user will click on one of his pictures or download them, that sensitive file will be sent back to the C2 server, and we can actually view that sensitive file for our own enjoyment. All right, and on to our next abuse scenario. This one talks about how we can actually enhance self-XSS attacks. And once again, in this scenario, we have a couple of things we need to have, just like in the previous one. We need to have some sort of file upload functionality for us to be able to upload the malicious service worker JavaScript file like previously. So we assume we have found some sort of a self-XSS. And to those of you who are unfamiliar exactly with what a self-XSS is, that's an XSS that most of the time can only be exploitable under our own account. So it is bound to an account. And for that reason, you can't really exploit it on any other victim. It is bound to your account. There's not a whole lot you can do with it. You can't steal credentials because you need the victim to somehow log into your account. And even then, what you're going to steal, your own cookie, not a whole lot you can do with it. The next thing you're going to need to have is a login and logout CSRF. So to those of you who are unfamiliar, once again, login, logout CSRF is it's just a way for the attacker to firstly log out the victim out of his own account and log in back into the attacker account. So that's why we can trigger the XSS on the victim while it's still on self-XSS. So the abuse scenario would look something like that. We're going to upload the malicious JavaScript service worker file just in the previously into the main application. We're next going to trick the victim into visiting our own evil application. We're just going to send him a link. That application will in turn host an iframe, which will cause the victim to log out of his own account. So now the victim is logged out. And we're going forcibly logging in into the attacker account, which, as you remember, we have a self-XSS already in. So once he's going to log in into the attacker account and visit the page containing the self-XSS, the XSS is going to trigger, like previously, it's going to install the malicious service worker, and that service worker is going to run in the background under the normal application, but currently he's logged in as the attacker. So once again, not a whole lot we can do, but because we have an XSS and we have a service worker installed, we can once again log the user out of the application, and the next time the user is going to visit the application, logging into his own account, our service worker is just going to push an XSS payload like you saw in the previous abuse scenario, and now we have an XSS under the victim browser victim account. So we elevated that self-XSS, something that we usually can't really exploit in some way, into something that is exploitable. So that's nice. We're going to show you a little demo of exactly how this attack is going to actually look like. We have the victim logging into his own account using his own credential. You can see the actual profile page, let's call it, for the victim, not a whole lot of information in there. The next thing we're going to do is have the victim visit our malicious website with the iframe to actually log the victim out of his own account, as you can see, and then re-log him back into the attacker account, triggering the XSS, and we're going to redirect him back into the application after we forcibly log him out. As you can see, the XSS has already popped up, meaning we now have an XSS in the victim browser. Now the victim is going to log in back into his own account, but now the XSS is triggering under the victim account and not the attacker account. So we elevated that self-XSS into a normal XSS and even a persistent XSS under the victim profile, which is pretty nice. So to recap exactly what we have here and how we can actually abuse that, we need to set up a domain with an iframe to log out and log in the user into the attacker account. We need to trick the user to log in, to visit that site we just set up. You can just send him a link or pick your favorite phishing way. We need the actual iframe to trigger, log out the user, log in into the attacker account. We need a service worker to register via the self-XSS already in the attacker account, and that's it. Just choose your payload, choose what your XSS is going to do, and you have a normal XSS. Now, a couple of caveats, because while those scenarios does look promising, there's a couple of things we need to take into account. The first thing, as Daniel mentioned, is the scope. We need to make sure that the actual page we want to attack and the actual place where the JavaScript file we've uploaded ended in are having the same scope or pretty similar scope. We can, if the actual page we want to attack resides deeper in the tree than the place where the service worker file has been uploaded to, there's not a whole lot we can actually do. The second thing there is the MIME type. When we're uploading that JavaScript file, it has to be returned from the server with a JavaScript MIME type. So mostly application JavaScript or text JavaScript. But if that JavaScript file is going to return with a text plain MIME type, for example, that's not going to cut it. The browser will refuse to install the service worker because of the incorrect MIME type. So keep that in mind.
Right. OK. So we've showed you what are service workers, how you can abuse them. But now we're going to show you how you can mitigate those attacks, or try to mitigate those attacks. First of all, you can enforce the scope. You can set the uploaded file's depth deeper in the tree, meaning that if you have user content that is being uploaded, try to make that path deeper in the tree. So if someone uploads a service worker or malicious service worker, it will have less effect over other files. In sandbox domain, you can try to pick the path hierarchy to be very unique, and even if it has like timestamps or random strings or GUIDs or stuff like that. So uploaded files will only affect the file itself and no other file under the file hierarchy. Refrain from using slash as the scope with the response header. We have seen developers doing very lazy work and putting that response header on every served JavaScript file because they didn't want to specify it only on the specific service worker. So every uploaded service worker will have the global activation on your victim's browser, which is great for us, which is bad for them. You can also monitor requests that are coming with the service worker request header, which gets appended when you try to register new service workers. That header is being appended every time you try to register, so you can take a look of the file name itself. If you see any irregular file names, you can try to make a rule to block those requests. You can also try to implement real user monitoring, or RUM for shorthand. RUM is a passive monitoring technique that basically gives you visibility into the experience of your clients, of your web clients. You can measure the experience of your clients. So if you have a client that suffers from poor performance, one of the reasons could be local denial of service via service workers. Again, it is under some restrictions if the local denial of service has happened only on static content and not just the web page itself. You can also try to monkey patch the register function to try to log any unusual activity on that function on your client's browsers. You can look if someone is invoking that method with a file name that doesn't suit your legit service worker in your application. If that happens, you can alert your SOC team, or you can just deny that invocation. You would also like to note some past work on service workers. mainly some great guides from Google, which are targeted for developers, but they have assisted us much during this research. They are very thorough and very functional. So, what we want you to take away from this presentation. First of all, I hope we introduced you a new web API that you can use and abuse. And they are very useful and they give clients a very good web experience. They can enhance dramatically the experience of your web clients, but they can also cause harm. So you should use them carefully in your application. Also, sandbox domain were treated for a long time as sandbox for sure because many thought they didn't have any vulnerabilities. But sandbox domains are just a method, not the actual result. You should always try to monitor those sandbox domain for unusual activities. Thank you very much. Questions?
Thank you for the presentation. It was really good. I was keep thinking about how this could be applicable to the vendor attacks, supply chain kind of attacks. So let's say if a vendor got compromised and now many websites are actually loading JavaScript files from the vendors. So can compromised vendor inject service worker requests which will be loaded up on our site, and every time someone visits, or actually every time the victim visits our site, and this service worker will work in the background. Like, I hope you understood my question.
Sure, yeah.
Like,
basically, one of the limitations for service workers is they had to be loaded from the same origin. So supply chain attacks usually refer to third-party scripts that third-party domains are hosting. Now, if those third-party domains have some sort of a malicious JavaScript code injected, they can register a service worker, but the file itself must reside on the actual application domain. So they had initially have to upload a malicious service worker into the application itself. Then they could actually register that service worker, but they have a prerequisite of uploading that file into the application, into the server of the main application. They can register it, but the file has to be same origin.
Okay, anybody else?
Say you were subject to this attack and you knew about it and you wanted to like remove all the service workers that have been maliciously installed on a user's browser. Is that easy to do once you've like regained control?
Definitely. Well, the service worker object under the navigator object has other functions than just register. You can see all the installed service workers, and you can unregister those from the browser. So if you have inspected such activity, you can push a fix to unregister those malicious service workers, and hopefully that will be enough, so they're not that persistent.
Okay, next question.
Just to follow up to that, so presumably a service worker would not be able to inject something into the response, which would stop the unregistered coming in a new file. Does that make sense?
Yeah, that's why I said hopefully, because once the service worker has a foothold on your client's browser, they can dynamically remove the piece of code that actually removes their service worker from the browser. But they have to be very aware of that piece of code. So that's like a catch-22 for that matter.
Does a service worker persist through like incognito mode or something like that?
So it does work in incognito. The only way that it doesn't work, it's over HTTP. It has to be over secure channels, but it does work in incognito.
So to remove other service workers, what level of permissions do you need to be running in to be able to see all the other service workers?
There is no special permission. I mean, in the web, most of the JavaScript code runs on the same level, so you don't have like to be in a very special, special ring for that. It's like that's pretty straightforward.
So if I manage to distribute my Bitcoin miner, I could go cancel all the other service workers that were running and hog the CPU?
But you should take in consideration that by eliminating the existence of other like legit service workers, you're going to affect the experience of the actual website. So users might see like a degraded experience and notice that something is going wrong other than the CPU is going on fire. So yeah.
I think they would probably just call IT and say it's not working. So you'd have some amount of time, right?
Yeah.
Scale it up.
So a service worker can intercept requests when you're on the website and modify the responses or change the headers. If you've installed a service worker, can it do anything when the victim is not at that website? Like, can it run in the background when there's no tabs for that site open?
So that's a good question. Actually, the service workers are bounded to a page. Service worker needs clients to be operative. Clients are considered either tabs or new windows open under that scope. And if there are no clients, there is no need for the service worker to be alive. So it usually gets terminated.
Okay. Anybody else? Excuse me.
Thanks a lot for the presentation. I guess my question is, since you have the mechanisms to kind of figure the kind of browser that the end user is using to visit the website or the service, are there any browser-specific implementations that you should look out for? Say, hey, we should prioritize Firefox, Safari over Chrome or any other browser. Even if it's like diminishing the end user experience, it should kind of overhaul the security overall of the service, basically. Is there anything we can do browser specific, or is that pretty much standardized?
Well, the W3C has submitted the RFC for the service worker API, and most of the vendors have implemented it some sort of the same. They all share the same functionalities, but obviously the source code is different, so every browser is prone to different attacks. There's usually like a cat and mouse scenario where like 3 years ago, someone found out a vulnerability to bypass the scope restrictions. So after Chrome has patched it, every other vendor like was hurried to patch that vulnerability after that. So they share basically the same functionalities, the same security level.
Okay, any more questions? I guess not. So let's give a big hand to our speakers, Daniel and Shay. Thank you very much.